Okay, so we're doing something called binomial. And to be a binomial, it has to either be success or failure. You're going to only do it a certain number of times. They're independent from each other. Like this one doesn't affect the one before it. And lastly, if you had a 40% chance of success, then you'd have a 1 minus 40 chance of failure, which is like a 60% chance of failure. So 40% success, 60% failure. Here is a typical question. I'm going to just jump right into it. Given that he typically makes 40% of his shots in a game, let's say he gets 3 shots, then what's the probability he's going to make 2 out of the 3 shots? That is a complicated question. That's why we've got this awesome formula to figure it out for us. Okay, if he's normally a 40% accurate shooter in pond hockey, and he is a goal scorer, however you'd say it, then here's how you'd answer it. I'm just going to jump right to the ending. C is combinations. There's a different combinations of ways he could do that. I said make 2 out of 3. So the question was, given normally 40%, then what's the probability of making 2 out of 3 shots? All right, so you go C for there's a lot of different ways you can do that. You could make the first 2 and then miss the last one. You could make the first one, miss the middle one, and then make the last one. You get what I mean? There's a lot of combinations of how you could do that. And this first C will figure that out for us. Somebody figure out, it's really simple. What numbers do you think go here and here, given this situation? Yeah. So which ones should be where? 3 and then the 2. All right, good. So he's got 3, choose 2. There's a lot of different ways he could score those 2 goals. Then we just have to multiply by what is it that actually happens here? Do you get there's a 40% chance he's going to make, and then another 40% chance, don't write this down yet, he's going to make, and then we want 1 miss. Do you get it doesn't matter if I rearrange that, it's still the same exact thing. Like if the miss is in the middle, I just move this to the middle, and it's going to be the same decimal either way. So guess what we do? We simplify it down and say 40%, 2 of those. Do you get how putting it to the second power means the same thing as 40 times 40? Times 60%, and there's only 1 of those. And these things also balance. Watch this. There's 2 makes, right, out of 3. This and this should always match. Then what do you think that 3 over here goes with? Yep. These together have to add up to 3. All right. Moral of the story, if you can type that into your calculator, you'll find out the probability he will make 2 out of 3 shots. Now let's think about this first of all. You get 2 out of 3 shots is 67% make, and he's only a 40% make guy. Do you get this is pretty unlikely then in the real world? He's only supposed to make 40% of the time, and we're saying he's going to make 2 out of 3, which is like about 60%. So he's not likely to have this happen. All right, figure out exactly what this comes to with your calculator. 3, choose 2, and then 0.4 to the 2 and 0.6 to the 1. I'll pause while you calculate that. All right, so when you put in 3C2, I can do that in my head. 3 factorial over 3 minus 2 is 1 factorial with an extra one of these because C, it's got an extra thing on the bottom. All right, and that just means it's 3. So this is just 3 times 0.4 to the 2 times 0.6, and that I can't do in my head very well. So what's the grand total? 0.96. Would you guys agree that rounds to about 10% chance he's going to do that? Okay, somebody typed it wrong. All right, so what was it supposed to be? Sorry. 288. All right. It's about a 29% chance. Boy, he's much more likely to do that. All right. But still, just think about that. That's not a high probability he's going to do that. What's more likely out of his 3 shots he's going to get this game? 1 out of the 3 is probably more likely. Do you get that if we add up the probability of him getting 0 shots, or sorry, him getting 1 goal or 2 goals or 3 goals, that will be everything possible. And therefore, it'll add up to 100%. We already figured out there's a 30% chance he's going to do this, which is 2 out of 3. Let's figure out 1 out of 3 now. It's more likely, so I bet it'll be higher than 30% chance. So you go 3C1, very similar. Go ahead, do it with your calculator. Now we're figuring out the probability he's going to make 1 out of the 3 goals, given he's normally a 40% scorer. And you don't have to write out 2 40s and 1 60. In fact, in this case, we don't want that. This is 1 make, and these are makes. So we got 1 of those, and therefore there must be 2 of those. All right, 3C1 I can do without your calculator's help. 3 minus the 1 is 2 factorial over an extra 1 of these factorial. Extra that there. And this turns out to be, that's kind of weird. Came out to 3 again. Can happen. There's 3 ways that you can miss 2 and make 1. Doesn't that kind of make sense? It's kind of like exactly the same thing as make 1, miss 2, except reversed. So there's 3 ways you could do that. Either you miss, and then make, because you got to place 2 misses and 1 make. So it's kind of like the other one. All right, anyway, so that comes out to 3, and you times it by 0.4, and then you times it by 0.6 to the second, and what did you get? 432. That's about a 43% chance that that's going to happen. The other one was 29. This one's 43. That leaves us like 30% chance left of something else happening. What's that? It's going to miss all of them. Would you please right now figure out the probability he will miss all the shots? He gets 3 shots. He makes 0. Now I ask you, how many different ways can he miss all the shots? Could he miss in that? Yeah, there's only one way to do it, isn't there? Yeah. So therefore, what is 3 choose 0? 1. It's 1. If you use the calculator for it, it's still 1. And how many 40% does he need then? 0. And do you get the formula doesn't like fail right there? Because what's anything to the 0 power? It's equal to 1. And how many 60% is he going to have? 3. And I could either write out 3.60s or put 0.60 to the third. So in the end, this is just 1, this is just 1, and then so it's really just 0.60 to the third. And doesn't that make sense? Miss, miss, miss. Probability, 60, 60, 60. Multiply them all together. What was it? All right. So when you add them all up, the other one's added to about 80%. This adds up to the other 20, and there we go. Does that make sense? Oh, there is a chance of make. Let's do that one. It's a very small chance because he only makes 40% of the time, so making all 3 is going to be really small. But you're right. There's a chance of it. So you choose 3. 0.4 to the third. 0.60 to the 0. 6%? Can anybody verify 6%? Lots of people. Okay, good. Sorry. I was thinking that the others didn't quite add up to 70, but or to 80, but yes. Absolutely. Since it was 100% chance total, and the other 3 added up to how much left, and I bet you there was about 6% left. And that was all the things that could happen when he shoots. So here is to me, this is the way, this sums it up really well. Do you get that if somebody is a 70% free throw shooter, and they get 10 free throws during the game, wouldn't you think they'd make 7 out of 10? But there's only a small probability of that. Isn't that a weird concept? If you're normally a 70% free throw shooter and you get 10 free throws, you would think you'd get 7 out of 10. But do you get there's a fairly high chance you're going to also could get 8 out of 10? And there's a somewhat decent chance you're only going to get 6 out of 10? And there's also a chance you're going to get 10 out of 10. You see what I mean? They have to all add up to 100%, and there have to be chances of each thing. So there is not a 100% chance that you're going to make 7 out of 10, even though you're a 70% free throw shooter. In fact, let's figure it out. Would you please figure out for me? If you know how to use this formula yet, you'll get it. I got 10 shots, because maybe I'm the guard in the basketball game, and they give me the ball at the end of the game because they want to foul. They want people to foul me because even though 70% isn't awesome, maybe I'm the best free throw shooter on the team, and so sometimes that happens, and the guy gets a lot of shots at the end of the game because if his team is ahead, the other team tries to like foul him a lot to try to get that chance to stop the clock and get turnovers. So you should have been doing 10 C7, 70% chance, and then we have 7 of those. 30% chance, and we have 3 of those. And multiply it all out. What did you get, sir? Can anybody verify the 27%? Several people are verifying it. All right, good. I know they're fast. Well, you don't even have a calculator, so how are you doing it? Yeah, you probably should take care of that. I'll pause for a second. Once you know the formula, it is pretty easy, isn't it? I mean, this isn't that hard. So how does it become this hard thing? Well, only because we make the problems more complicated. It's not just what's the probability of making 7 shots, which this is. Here's your 27%. But we'll say, what's the probability he's going to make at least 7 shots? Because you get it if you're on his side, you want him to make his average or a little better than his average, which would be awesome. Like, he's normally only a 70% free throw shooter, but he shot 90% in that game. What is the chance of that? If I say or, do you remember that that's kind of like a clue that we got a big answer? Because we can win if he gets 7 or 8 or 9 or 10 free throws. So we have to figure it out. Here's the probability of 7. Now we got to do the exact same thing except for 8. And then we got to do the exact same thing except for 9. And then the exact same thing except for, holy crap, that's going to add up, isn't it? Yes, and it's a pain, but that's how you do it. So let's just do one more. Figure out probability he's going to make 8. And if this is 8, you quickly get used to this. That goes here. And then this other number has to make it add up to a total of 10. So there must be 8 of the one, there must be 2 of the other. And there we go. And what's the probability of that one? Think about it. Should it be more or less? Less. Because 70% was the thing that was most likely to do, because he's a 70% free throw shooter. So getting more than 70%, like 8 out of 10, there's less chance of that. What was it? 23. Do you get how it wasn't that much different? All right. Would you expect then, that he made an extra one, right? Would you expect that that would be similar to the probability if he misses an extra one? You know what I mean? Like, just for fun, quick, if you got fast fingers, change this to, this is one more than he's supposed to make. This is one less than he's supposed to make. And I bet you that it ends up coming out very similar to 23%. Ten choose 6.70 to the 6, 0.30 to the 4. 20%. All right, I can believe that it won't be exactly the same, but anybody verify the 20%? A couple people got the same thing. Good. Okay. So what I'm trying to say is there are patterns here that kind of make sense when you think about them in the real world, but if I'm going to get this answer I originally proposed, which was what is the probability he's going to make at least 7 out of the 10 shots? We got to do 7 and 8 and add these together. And then just keep going. And you got to do 10 choose 9 and 10 choose 10. That's the most he could make. So you take all of those, and ors mean add. So you just take those and add them all up. All right, now that kind of gives you a summary of the most complicated ones. Here's one that's kind of just a little tweak on that. What's the probability he'll make at least 1? Wouldn't you agree it's out of 10 shots, if he's normally a 70% free throw shooter, it's a very high probability? Do you really want to have to do and the probability of 1, probability of 2, and 3, and 4, and 5, and 6, and 7, and 8, and 9, and 10? Or would there be a smarter way? Subtract the probability of him missing all of them. Good. Would you please figure that out? I'm going to say it again. He's a 70% free throw shooter, and we were thinking at first we'd investigate the probability to actually get 7 out of 10. Now we're saying at least 1 out of 10. And again, you can figure out 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10 and add all 10 things up. Or the smart way is 1 minus the probability that he does miss all of them. Because there's this big list of, and this is making 10, 9, 8, 7, 6 shots, 5, 4, 3, 2 shots, 1 shot, or he could do 0 shots. And we can either add up all of those or find this one and go 1 minus that. Get what I just said there? So then you should have done 10C0. We're choosing the possibility he makes 0 out of 10. 70% he has 0. And how many misses then? 30% chance of that, and it happens every single time, which is all 10. And that's your probability of that, which is really small. In fact, it's probably so small, the calculator might have even gone into a weird mode that's like E negative whatever. Okay, so what E negative what? 5.9 E negative 6. That means I take 5.9 and I move the decimal, how far? 6 spots to the left or to the right? 1, 2, 3, 4, 5, 6. That is how unlikely it is that somebody would miss all 10 shots at the end of the game. But can you get, by the time the kid has missed like 4, his confidence is destroyed. He's just missed 4 in a row. And now he's going to feel like, oh, I can't, oh my gosh, what if I miss all my free throws? And he's going to start psyching himself out, and it's going to get worse and worse. All right. So it rounds to 0%. That's weird, but it's the right answer. So therefore, would you agree that with rounding considered, there's a 100% chance he's going to make at least 1? Yeah. You take 1 minus 0, it's going to be 100%. And I think we all know it's like a 99.99999, but we never ask you to go that far in decimals. Chance that he's going to make at least 1. All right, let's figure out the probabilities. But I'm willing to admit, unlike these formulas, that it is kind of dependent in the real world, because if you get on a roll, and I hate to say it, it's kind of true in life too. If you get on a roll like grade-wise, I don't know if you've ever had that feeling like, oh, I'm getting really good grades. You tend to keep getting good grades because you reinforce that with, I've been getting really good grades, and I'm going to keep trying hard to get those good grades. And kids that get bad grades, it's a vicious cycle the other way around. Like, I already got crappy grades. What's the point in trying? And then they keep getting crappy grades because they stop trying. So there is vicious cycles in the up, and there's vicious cycles in the down. Math often doesn't account for those. In simple scenarios like this, we just tend to say, well, you're normally a 70% free throw shooter. Like, it's going to be that way all the time. In the big pressure games, I bet you could do a study on it. And I bet you people's free throw shooting average goes down in those big pressure games just because there's so much pressure on them. Okay, so I've taught you everything you need to know for binomial probability. And I want to do a couple that are just off the sheet here. And we're not going to do the Ricky Rubio thing. We're going to go to this one. I want you to look at this dogs and cats problem. Do you get that there is the paths that we have highlighted here are getting 2 dogs and 1 cat? So there's 3 ways you could do that. This part of the formula works out how many different ways that thing could happen. And this part is really simple. It's 2 dogs, 1 cat. The probability is all just multiplied. And it's just like, how many different ways could that happen? All right, good enough on that. All right, so here is a simple, here's the problem. See if you can figure it out. Use binomial. You can use a calculator. And let's see if you get the right answer for the Major League Baseball player has a 295 average. What's the probability he gets a hit in exactly 4 of his next 10 at-bats? I'll warn you, it's not super likely, because he's actually more likely to get 3 hits. It's closer to his average. All right, don't let this part stop you. I think all of you know that it's 10C4. But how do you do a percent if it's got 3 decimal places? It's the same way. You just go 295. And now you go to 3 decimal places like we did on the last one. So this one would be 705. Because they have to add up to 100% together, right? And then this one would have to be the 4s, 4 hits. And this has to be 6 because these together have to add up to 10. And these 2 are the same. Raise your hand if you set that up right. Okay, good. Now what if I changed it to at least 4 hits? We'd do 4 hits and then add it to 5 hits, and then 6, 7, 8, 9, and 10. It'd be a pain. We usually don't do that. We'll usually say at least 9 out of 10. And then you'll say, okay, so it's going to be 9 or 10. You just have to add 2 of them. You know what I mean? If I said he makes a hit, he gets at least 9 hits. And you just have to figure out 9 and 10. And you add them together. We're not going to make you want to. We understand it's going to be complicated to add a whole bunch of them. The other one we do a lot is, what's the probability he gets at least 1? And so then you go 1 minus the probability he gets 0, which would be 10, choosing to hit 0 times 295, 0 of those. The 705 is all of them. That's at least 1, which means 1 or 2 or 3 or 4 or 5. And what is the one thing you can't be? 0. So you go 1 minus 0 then. Okay, I think that covers it. So we're ready to get to your homework for today. I'm going to pause for a second while I pull it. So here's our homework. I'd say it's good to actually figure out all of them. 1, 2, 0. Actually, didn't do 3. What? We got 1, 2, 4, 5, 6, 0. Oh, it's at the very top. Okay, cool. So it does pretty much all of them. And then this is that at least thing. So if you do all of those, then once you've figured out all the probabilities, you can say, what's the probability it'll be at least 6 times? Then you'll do like 6 or 7. All right. So, I don't know, I think we're going to skip a bunch of these because I'm going to start on problem 3. And that it uses the same data from problem 1, but it'll save you a bunch of time. And the ones that are really challenging are the ones that are like the Kevin Garnett question, number 5. He'll make exactly 8 or 9, like part C, 8 or 9 of the next 10. He'll miss all. Anyway, so they use the same percentages up here. The illusionist's coin. Wait a minute. Where's the percentages for the? Oh, there we go. Kevin Garnett's making 781 of his free throw attempts. 0.781. Yes, if it's 8 or 9, you just add 8. Probability of 8. Exactly. All right. And then I think I'm just going to have you start on problem 3 and then do the rest. So that'll be good practice for tonight. That's all I got for you for today.